Chapter 8, Part 2 of The Outline of Science. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. This recording is by Mark Smith of Simpsonville, South Carolina. The Outline of Science, Volume 1, by J. Arthur Thomson. Chapter 8, Part 2. The Electron Theory, or the New View of Matter. The Structure of the Atom. There is general agreement amongst all chemists, physicists, and mathematicians upon the conclusions which we have so far given. We know that the atoms of matter are constantly, either spontaneously or under stimulation, giving off electrons or breaking up into electrons, and they therefore contain electrons. Thus we have now complete proof of the independent existence of atoms and also of electrons. When, however, the man of science tries to tell us how electrons compose atoms, he passes from facts to speculation, and very difficult speculation. Take the letter O, as it is printed on this page. In a little bubble of hydrogen gas no larger than that letter, there are trillions of atoms, and they are not packed together, but are circulating as freely as dancers in a ballroom. We are asking the physicist to take one of these minute atoms and tell us how the still smaller electrons are arranged in it. Naturally, he can only make mental pictures, guesses, or hypotheses, which he tries to fit to the facts, and discards when they will not fit. At present, after nearly 20 years of critical discussion, there are two chief theories of the structure of the atom. At first, Sir J. Thomson imagined the electrons circulating in shells, like the layers of an onion, round the nucleus of the atom. This did not suit, and Sir E. Rutherford and others worked out a theory that the electrons circulated round a nucleus rather like the planets of our solar system revolving round the central sun. Is there a nucleus, then, round which the electrons revolve? The electron, as we saw, is a disembodied atom of electricity. We should say, of negative electricity. Let us picture these electrons all moving round in orbits with great velocity. Now it is suggested that there is a nucleus of positive electricity, attracting or pulling the revolving electrons to it, and so forming an equilibrium. Otherwise the electrons would fly off in all directions. This nucleus has been recently named the proton. We have thus two electricities in the atom. The positive equals the nucleus. The negative equals the electron. Of recent years, Dr. Langmuir has put out a theory that the electrons do not revolve round the nucleus, but remain in a state of violent agitation of some sort at fixed distances from the nucleus. But we will confine ourselves here to the facts, and leave the contending theories to scientific men. It is now pretty generally accepted that an atom of matter consists of a number of electrons, or charges of negative electricity, held together by a charge of positive electricity. It is not disputed that these electrons are in a state of violent motion or strain, and that therefore a vast energy is locked up in the atoms of matter. To that we will return later. Here, rather, we will notice another remarkable discovery which helps us to understand the nature of matter. A brilliant young man of science who was killed in the war, Mr. Moseley, some years ago showed that, when the atoms of different substances are arranged in order of their weight, they are also arranged in the order of increasing complexity of structure. That is to say, the heavier the atom, the more electrons it contains. There is a gradual building up of atoms containing more and more electrons from the lightest atom to the heaviest. Here it is enough to say that as he took element after element, from the lightest, hydrogen, to the heaviest, uranium, he found a strangely regular relation between them. If hydrogen were represented by the figure 1, helium by 2, lithium 3, and so on up to radium, then uranium should have the figure 92. This makes it probable that there are in nature 92 elements. We have found 87, and that the number Mr. Moseley found is the number of electrons in the atom of each element. That is to say, the number is arranged in order of the atomic numbers of the various elements. The new view of matter. Up to the point we have reached, then, we see what the new view of matter is. Every atom of matter, of whatever kind throughout the whole universe, is built up of electrons in conjunction with a nucleus. From the smallest atom of all, the atom of hydrogen, which consists of one electron rotating round a positively charged nucleus, to a heavy, complicated atom, such as the atom of gold, constituted of many electrons and a complex nucleus, we have only to do with positive and negative units of electricity. The electron and its nucleus are particles of electricity. All matter, therefore, is nothing but a manifestation of electricity. The atoms of matter, as we saw, combine and form molecules. Atoms and molecules are the bricks out of which nature has built up everything: ourselves, the earth, the stars, the whole universe. But more than bricks are required to build a house. There are other fundamental existences, such as the various forms of energy, which give rise to several complex problems. And we have also to remember that there are more than 80 distinct elements, each with its own definite type of atom. We shall deal with energy later. Meanwhile, it remains to be said that, although we have discovered a great deal about the electron and the constitution of matter, and that while the physicists of our own day seem to see a possibility of explaining positive and negative electricity, the nature of them both is unknown. There exists the theory that the particles of positive and negative electricity, which make up the atoms of matter, are points or centers of disturbances of some kind in a universal ether, and that all the various forms of energy are, in some fundamental way, aspects of the same primary entity which constitutes matter itself. But the discovery of the property of radioactivity has raised many other interesting questions, besides that which we have just dealt with. In radioactive elements, such as uranium, for example, the element is breaking down. In what we call radioactivity, we have a manifestation of the spontaneous change of elements. What is really taking place is a transmutation of one element into another, from a heavier to a lighter. The element uranium spontaneously becomes radium, and radium passes through a number of other stages until it, in turn, becomes lead. Each descending element is of lighter atomic weight than its predecessor. The changing process, of course, is a very slow one. It may be that all matter is radioactive, or can be made so. This raises the question whether all matter in the universe may not undergo disintegration. There is, however, another side of the question, which the discovery of radioactivity has brought to light, and which has effected a revolution in our views. We have seen that in radioactive substances the elements are breaking down. Is there a process of building up at work? If the more complicated atoms are breaking down into simpler forms, may there not be a converse process, a building up from simpler elements to more complicated elements? It is probably the case that both processes are at work. There are some 80-odd chemical elements on the earth today. Are they all the outcome of an inorganic evolution, element giving rise to element, going back and back to some primeval stuff from which they were all originally derived infinitely long ago? Is there an evolution in the inorganic world which may be going on, parallel to that of the evolution of living things? Or is organic evolution a continuation of inorganic evolution? We have seen what evidence there is of this inorganic evolution in the case of the stars. We cannot go deeply into the matter here, nor has the time come for any direct statement that can be based on the findings of modern investigation. Taking it all together, the evidence is steadily accumulating, and there are authorities who maintain that already the evidence of inorganic evolution is convincing enough. The heavier atoms would appear to behave as though they were evolved from the lighter. The more complex forms, it is supposed, have evolved from the simpler forms. Moseley's discovery, to which reference has been made, points to the conclusion that the elements are built up one from another. Other new views. We may here refer to another new conception to which the discovery of radioactivity has given rise. Lord Kelvin, who estimated the age of the Earth at 20 million years, reached this estimate by considering the Earth as a body which is gradually cooling down, losing its primitive heat like a loaf taken from the oven, at a rate which could be calculated, and that the heat radiated by the sun was due to contraction. Uranium and radioactivity were not known to Kelvin, and their discovery has upset both his arguments. Radioactive substances, which are perpetually giving out heat, introduce an entirely new factor. We cannot now assume that the Earth is necessarily cooling down. It may even, for all we know, be getting hotter. At the 1921 meeting of the British Association, Professor Rayleigh stated that further knowledge had extended the probable period during which there had been life on this globe to about 1,000 million years, and the total age of the Earth to some small multiple of that. The Earth, he considers, is not cooling, but contains an internal source of heat from the disintegration of uranium in the outer crust. On the whole, the estimate obtained would seem to be in agreement with the geological estimates. The question, of course, cannot in the present state of our knowledge be settled within fixed limits that meet with general agreement. As we have said, there are other fundamental existences which give rise to more complex problems. The three great fundamental entities in the physical universe are matter, ether, and energy, so far as we know. Outside these there is nothing. We have dealt with matter. There remain ether and energy. We shall see that just as no particle of matter, however small, may be created or destroyed, and just as there is no such thing as empty space, ether pervades everything, so there is no such thing as rest. Every particle that goes to make up our solid earth is in a state of perpetual, unremitting vibration. Energy is the universal commodity on which all life depends. Separate and distinct as these three fundamental entities, matter, ether, and energy, may appear, it may be that, after all, they are only different and mysterious phases of an essential oneness of the universe. The future. Let us, in concluding this chapter, give just one illustration of the way in which all this new knowledge may prove to be as valuable practically as it is wonderful intellectually. We saw that electrons are shot out of atoms at a speed that may approach 160,000 miles a second. Sir Oliver Lodge has written recently that a 70th of a grain of radium discharges at a speed 1,000 times that of a rifle bullet 30 million electrons a second. Professor Le Bon has calculated that it would take 1,340,000 barrels of powder to give a bullet the speed of one of these electrons. He shows that the smallest French copper coin, smaller than a farthing, contains an energy equal to 80 million horsepower. A few pounds of matter contain more energy than we could extract from millions of tons of coal. Even in the atoms of hydrogen, at a temperature which we could produce in an electric furnace, the electrons spin round at a rate of nearly 100 trillion revolutions a second. Every man asks at once, will science ever tap this energy? If it does, no more smoke, no mining, no transit, no bulky fuel. The energy of an atom is of course only liberated when an atom passes from one state to another. The stored-up energy is fortunately fast-bound by the electrons being held together, as has been described. If it were not so, the Earth would explode and become a gaseous nebula. It is believed that someday we shall be able to release, harness, and utilize atomic energy. I am of opinion, says Sir William Bragg, that atom energy will supply our future need. 1,000 years may pass before we can harness the atom, or tomorrow might see us with the reins in our hands. That is the peculiarity of physics. Research and accidental discovery go hand in hand. Half a brick contains as much energy as a small coal field. The difficulties are tremendous, but as Sir Oliver Lodge reminds us, there was just as much skepticism at one time about the utilization of steam or electricity. Is it to be supposed, he asks, that there can be no fresh invention? That all the discoveries have been made? More than one man of science encourages us to hope. Here are some remarkable words written by Professor Soddy, one of the highest authorities on radioactive matter, in our chief scientific weekly, Nature magazine, November 6, 1919. Quote, "The prospects of the successful accomplishments of artificial transmutation brighten almost daily. The ancients seem to have had something more than an inkling that the accomplishment of transmutation would confer upon men powers hitherto the prerogative of the gods. But now we know definitely that the material aspect of transmutation would be of small importance in comparison with the control over the inexhaustible stores of internal atomic energy to which its successful accomplishment would inevitably lead. It has become a problem, no longer redolent of the evil associations of the age of alchemy, but one big with a promise of a veritable physical renaissance of the whole world." End quote. If that promise is ever realized, the economic and social face of the world will be transformed. Before passing on to the consideration of ether, light, and energy, let us see what new light the discovery of the electron has thrown on the nature and manipulation of electricity. What is electricity? The nature of electricity. There is at least one manifestation in nature, and so late as 20 years ago it seemed to be one of the most mysterious manifestations of all, which has been in great measure explained by the new discoveries. Already, at the beginning of this century, we spoke of our age of electricity, yet there were few things in nature about which we knew less. The electric current rang our bells, drove our trains, lit our rooms, but none knew what the current was. There was a vague idea that it was a sort of fluid that flowed along copper wires as water flows in a pipe. We now suppose that it is a rapid movement of electrons from atom to atom in the wire or wherever the current is. Let us try to grasp the principle of the new view of electricity and see how it applies to all the varied electrical phenomena in the world about us. As we saw, the nucleus of an atom of matter consists of positive electricity which holds together a number of electrons or charges of negative electricity. Footnote: the words positive and negative electricity belong to the days when it was regarded as a fluid. A body overcharged with the fluid was called positive. An undercharged body was called negative. A positively electrified body is now one whose atoms have lost some of their outlying electrons, so that the positive charge of electricity predominates. The negatively electrified body is one with more than the normal number of electrons. End of footnote. This certainly tells us to some extent what electricity is and how it is related to matter, but it leaves us with the usual difficulty about fundamental realities. But we now know that electricity, like matter, is atomic in structure. A charge of electricity is made up of a number of small units or charges of a definite constant amount. It has been suggested that the two kinds of electricity, that is, positive and negative, are right-handed and left-handed vortices or whirlpools in ether, or rings in ether, but there are very serious difficulties, and we leave this to the future. What an electric current is. The discovery of these two kinds of electricity has, however, enabled us to understand very fairly what goes on in electrical phenomena. The outlying electrons, as we saw, may pass from atom to atom, and this on a large scale is the meaning of the electric current. In other words, we believe an electric current to be a flow of electrons. Let us take, to begin with, a simple electrical cell in which a feeble current is generated, such a cell as there is in every house to serve its electric bells. In the original form, this simple sort of battery consisted of a plate of zinc and a plate of copper immersed in a chemical. Long before anything was known about electrons, it was known that, if you put zinc and copper together, you produce a mild current of electricity. We know now what this means. Zinc is a metal the atoms of which are particularly disposed to part with some of their outlying electrons. Why, we do not know, but the fact is the basis of these small batteries. Electrons from the atoms of zinc pass to the atoms of copper, and their passage is a current. Each atom gives up an electron to its neighbor. It was further found long ago that if the zinc and copper were immersed in certain chemicals which slowly dissolved the zinc, and the two metals were connected by a copper wire, the current was stronger. In modern language, there is a brisker flow of electrons. The reason is that the atoms of zinc which are stolen by the chemical leave their detachable electrons behind them, and the zinc has therefore more electrons to pass on to the copper. Such cells are now made of zinc and carbon immersed in sal ammoniac, but the principle is the same. The flow of electricity is a flow of electrons, though we ought to repeat that they do not flow in a body as molecules of water do. You may have seen boys place a row of bricks, each standing on one end, in such order that the first, if it is pushed, will knock over the second, the third, and so on to the last. There is a flow of movement all along the line, but each brick moves only a short distance. So an electron merely passes to the next atom, which sends on an electron to a third atom, and so on. In this case, however, the movement from atom to atom is so rapid that the ripple of movement, if we may call it so, may pass along at an enormous speed. We have seen how swiftly electrons travel. But how is this turned into power enough even to ring the bell? The actual mechanical apparatus by which the energy of the electron current is turned into sound, or heat, or light, will be described in a technical section later in this work. We are concerned here only with the principle, which is clear. While zinc is very apt to part with electrons, copper is just as obliging in facilitating their passage onward. Electrons will travel in this way in most metals, but copper is one of the best conductors. So we lengthen the copper wire between the zinc and the carbon until it goes as far as the front door and the bell, which are included in the circuit. When you press the button at the door, two wires are brought together, and the current of electrons rushes round the circuit, and at the bell its energy is diverted into the mechanical apparatus which rings the bell. Copper is a good conductor, 6 times as good as iron, and is therefore so common in electrical industries. Some other substances are just as stubborn as copper is yielding, and we call them insulators, because they resist the current instead of letting it flow. Their atoms do not easily part with electrons. Glass, vulcanite, and porcelain are very good insulators for this reason. What the dynamo does. But even several cells together do not produce the currents needed in modern industry, and the flow is produced in a different manner. As the invisible electrons pass along a wire, they produce what we call a magnetic field around the wire. They produce a disturbance in the surrounding ether. To be exact, it is through the ether surrounding the wire that the energy originated by the electrons is transmitted. To set electrons moving on a large scale, we use a dynamo. By means of the dynamo, it is possible to transform mechanical energy into electrical energy. The modern dynamo, as Professor Soddy puts it, may be looked upon as an electron pump. We cannot go into the subject deeply here. We would only say that a large coil of copper wire is caused to turn round rapidly between the poles of a powerful magnet. That is the essential construction of the dynamo, which is used for generating strong currents. We shall see in a moment how magnetism differs from electricity, and will say here only that round the poles of a large magnet there is a field of intense disturbance which will start a flow of electrons in any copper that is introduced into it. On account of the speed given to the coil of wire, its atoms enter suddenly this magnetic field, and they give off crowds of electrons in a flash. It is found that a similar disturbance is caused, though the flow is in the opposite direction, when the coil of wire leaves the magnetic field. And as the coil is revolving very rapidly, we get a powerful current of electricity that runs in alternate directions, an alternating current. Electricians have apparatus for converting it into a continuous current where this is necessary. A current, therefore, means a steady flow of the electrons from atom to atom. Sometimes, however, a number of electrons rush violently and explosively from one body to another, as in the electric spark, or the occasional flash from an electric tram or train. The grandest and most spectacular display of this phenomenon is the thunderstorm. As we saw earlier, a portentous furnace like the Sun is constantly pouring floods of electrons from its atoms into space. The Earth intercepts great numbers of these electrons. In the upper regions of the air, the stream of solar electrons has the effect of separating positively electrified atoms from negatively electrified ones, and the water vapor, which is constantly rising from the surface of the sea, gathers more freely round their positively electrified atoms, and brings them down as rain to the earth. Thus the upper air loses a proportion of positive electricity, or becomes negatively electrified. In the thunderstorm we get both kinds of clouds, some with large excesses of electrons, and some deficient in electrons, and the tension grows until at last it is relieved by a sudden and violent discharge of electrons from one cloud to another, or to the earth, an electric spark on a prodigious scale. Magnetism. We have seen that an electric current is really a flow of electrons. Now, an electric current exhibits a magnetic effect. The surrounding space is endowed with energy which we call electromagnetic energy. A piece of magnetized iron attracting other pieces of iron to it is the popular idea of a magnet. If we arrange a wire to pass vertically through a piece of cardboard, and then sprinkle iron filings on the cardboard, we shall find that, on passing an electric current through the wire, the iron filings arrange themselves in circles round it. The magnetic force, due to the electric current, seems to exist in circles round the wire, an ether disturbance being set up. Even a single electron, when in movement, creates a magnetic field, as it is called, round its path. There is no movement of electrons without this attendant field of energy, and their motion is not stopped until that field of energy disappears from the ether. The modern theory of magnetism supposes that all magnetism is produced in this way. All magnetism is supposed to arise from the small whirling motions of the electrons contained in the ultimate atoms of matter. We cannot here go into the details of the theory, nor explain why, for instance, iron behaves so differently from other substances, but it is sufficient to say that here also the electron theory provides the key. The theory is not yet definitely proved, but it furnishes a sufficient theoretical basis for future research. The Earth itself is a gigantic magnet, a fact which makes the compass possible, and it is well known that the Earth's magnetism is affected by those great outbreaks on the Sun called sunspots. Now it has been recently shown that a sunspot is a vast whirlpool of electrons, and that it exerts a strong magnetic action. There is doubtless a connection between these outbreaks of electronic activity and the consequent changes in the Earth's magnetism. The precise mechanism of the connection, however, is still a matter that is being investigated. Ether and waves. The whole material universe is supposed to be embedded in a vast medium called the ether. It is true that the notion of the ether has been abandoned by some modern physicists, but whether or not it is ultimately dispensed with, the conception of the ether has entered so deeply into the scientific mind that the science of physics cannot be understood unless we know something about the properties attributed to the ether. The ether was invented to explain the phenomena of light, and to account for the flow of energy across empty space. Light takes time to travel. We see the sun at any moment by the light that left it 8 minutes before. It has taken that 8 minutes for the light from the sun to travel that 93 million miles odd which separates it from our Earth. Besides the fact that light takes time to travel, it can be shown that light travels in the form of waves. We know that sound travels in waves. Sound consists of waves in the air, or water, or wood, or whatever medium we hear it through. If an electric bell be put in a glass jar, and the air be pumped out of the jar, the sound of the bell becomes feebler and feebler until, when enough air has been taken out, we do not hear the bell at all. Sound cannot travel in a vacuum. We continue to see the bell, however, so that evidently light can travel in a vacuum. The invisible medium through which the waves of light travel is the ether, and this ether permeates all space and all matter. Between us and the stars stretch vast regions empty of all matter. But we see the stars, their light reaches us, even though it may take centuries to do so. We conceive then that it is the universal ether which conveys that light. All the energy which has reached the earth from the sun, and which, stored for ages in our coal fields, is now used to propel our trains and steamships, to heat and light our cities, to perform all the multifarious tasks of modern life, was conveyed by the ether. Without that universal carrier of energy we should have nothing but a stagnant, lifeless world. We have said that light consists of waves. The ether may be considered as resembling, in some respects, a jelly. It can transmit vibrations. The waves of light are really excessively small ripples, measuring from crest to crest. The distance from crest to crest of the ripples in a pond is sometimes no more than an inch or two. This distance is enormously great compared to the longest of the wavelengths that constitute light. We say the longest, for the waves of light differ in length. The color depends upon the length of the light. Red light has the longest waves, and violet the shortest. The longest waves, the waves of deep red light, are 7/250,000ths of an inch in length. This is nearly twice the length of deep violet light waves, which are 1/60,000th of an inch. But light waves, the waves that affect the eye, are not the only waves carried by the ether. Waves too short to affect the eye can affect the photographic plate, and we can discover in this way the existence of waves only half the length of the deep violet waves. Still shorter waves can be discovered until we come to those excessively minute rays, the X-rays. Below the limits of visibility. But we can extend our investigations in the other direction. We find that the ether carries many waves longer than light waves. Special photographic emulsions can reveal the existence of waves 5 times longer than violet light waves. Extending below the limits of visibility are waves we detect as heat waves. Radiant heat, like the heat from a fire, is also a form of wave motion in the ether, but the waves our senses recognize as heat are longer than light waves. There are longer waves still, but our senses do not recognize them. But we can detect them by our instruments. These are the waves used in wireless telegraphy, and their length may be, in some cases, measured in miles. These waves are the so-called electromagnetic waves. Light, radiant heat, and electromagnetic waves are all of the same nature. They differ only as regards their wavelengths. End of this part of Chapter 8.